Hello, Isaac here. Welcome to my first official video. The video that I did before was kind of official, but it was just more of an introduction. This video will be about chemistry, specifically about nomenclature, about naming chemicals and such, alkanes and combustion, as well as just a little overview on basic chemistry. So this is a very simple version of the periodic table. We have hydrogen, lithium, and potassium. Then we have beryllium, calcium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, helium, neon, and argon. These ones are these three. The reason why they have a 0 above and below is because they have no charge and they are unreactive and can't form any bonds, because they have a full outer shell of 8 electrons. On this side, hydrogen has 1 electron in its outer shell, which means it wants to lose 1, so it becomes positive, the same as lithium and potassium. Beryllium wants to also lose, but wants to lose 2, which means it becomes positive by 2, same as calcium. Boron wants to do losing as well. Boron and aluminium both lose 3, so they become positive 3. But carbon is interesting, as well as silicon, as its precursors that go down, is it can form 4 bonds, but it's not exactly, it's kind of weird. It can lose or gain, it can do both. It's kind of the reason why life is so centered around it. Then we have nitrogen. Okay, let me just fix that 3. That doesn't even look like a 3. That doesn't look like either. Close enough. Negative 3, that's nitrogen. It needs 3 electrons, which means it becomes negative by 3. And oxygen and sulfur, they have to gain 2 electrons, so negative 2. And the halogens, fluorine, chlorine, so on, they have to gain 1, so negative. This video will be mainly focused on just the interactions between hydrogen, carbon, and a little bit of maybe some others if I'm feeling it. The reason why I didn't include others because it would just be quite long, and this was just basically like a brief re-jog of memory. So carbon can form 4 bonds. It can form a triple bond and a single bond, 2 double bonds, and 4 single bonds. Nitrogen can form a triple bond. It can form 3 bonds. Oxygen can do 2 bonds, lithium 1 bond, all of these 1 bonds, 2 bonds, 3 bonds, 4 bonds, 3 bonds, 2 bonds, 1 bond, 0. So you can't have oxygen like this because that's 3. That just doesn't make sense. Also, throughout the video, I am also going to do kind of like a test in a way. I'm going to ask kind of like a question, like I'll put something on the board and then I'll ask a question and then you can pause the video and try and answer it. I'm going to do that I won't do too many because I don't, as I said at the last video, I don't want my videos to be too long. Otherwise, the video editor kind of just has an aneurysm, it doesn't work. Okay, now on to the main focus of the video. Nomenclature, alkanes, and combustion. So, what is an alkane? An alkane is a type of hydrocarbon. An example is CH4, that is a carbon bonded to 4 hydrogens. It is a gas at room temperature and it is the first alkane. It is also the smallest alkane and is a hydrocarbon, hydrogen and carbon. It is known as methane and it is the only alkane that is a gas, I'm pretty sure. Yes, because all of them are liquid. Okay, anyway, we have this now. Now, these are 2 ways you can write it. You have this method and then this method. You can also write it another way, but it doesn't really work with the first because the first alkane is too small. Well, let me just write the name. Methane. That's the first alkane. Now, and then now I'm just going to create a list of them, the first few important ones that we'll be going over today. Okay, so methane, as we just talked about, CH4, That's not 4, that's whatever that was. CH4. Now we have ethane. Can you guess what that's going to be? This wasn't like the question, but actually, wait. So you can guess, because it would be unfair otherwise. The equation for alkanes is C of N H of 2N plus 2. So since this is 1, 2 times 1 is 2, plus 2 is 4. And ethane is the second one, so 2 would go here. So what would it be? It would be, actually, you know what? I'll just put this up here, just as a reminder. Okay, the next one is C2H6, ethane. And now the third one, propane, C3H8, butane. Do you know what this one is? C4H10. And also pentane, C5H12. You can keep going. It goes from pentane to hexane, heptane, octane, nonane, decane, undecane, dodecane, and it just continues. But in this video, we'll be focusing on, I can't continue on my whiteboard, but like we'll go all the way up to octane, and that's it, because octane, something interesting about that, though. I'll give like a little thing about it. Now there's an alternative way to, drop that off, that's annoying. An alternative way to write alkanes and hydrocarbons, that are basically most big chemicals, is this. This has 1, 2, 3, 4, 5 points. Each of those points represents a carbon, and this connection is like a bond. And this, since it has 5, it is pentane, C5H12. Another way you could write it is basically under the covers of this. I'll just move this to the side a little bit. So this wouldn't be how I write it. It's not just because, look, see, there's 12 hydrogens. Well, you put the hydrogen, because remember, each carbon has to be full. So H, 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 H. So 3 hydrogens, 2, 2, 2. Another way you can write it, yes, there is more, is CH3, then a bracket. This bracket means, so we have CH2, since 1, 2, 3, since this is repeating, we can put a 3 down in the corner, which means it's repeated 3 times, and then the final CH3, which is equal to that. Yeah. I thought that was 6 for a second. Anyway, so that's pentane. And you can do this with others, and you can't actually do it with methane. With methane, you would just write it as CH4. Oh, and something interesting that's more important that I must add is when you remove 1 or 2 from one or two hydrogens from an alkane, you get a slightly different named hydrocarbon. So methane becomes methyl, which is CH3, and it is called a radical, which means it can't exactly exist by itself. But remember earlier when I was drawing it, how there's CH3 on both sides. You wouldn't say it's methyl, but remember methyl in the future. And ethane becomes ethyl if you C2H6 becomes 5, and so on for every hydrocarbon. You remove 1, it becomes an il at the end. Oh no, drop a pen. And I do some models here. This is the structure of methane. You have the carbon in the center, and you have the 4 hydrogens protruding from it. You've also done the same for ethane, which has 2 methyl groups. This is a hydroxide group, or a HO group, or OH group. There are many different ways to call it. It is a radical, again, since oxygen has a part left where it can connect. We'll talk about this in a sec. But just before then, remember how there's ills, there's also N's. So you know how it goes ane, replace the A with an E. So methane, which is CH2. Or carbon dihydrogen, which is a weird way to say it. This is another unstable radical that technically doesn't exist on its own, but this is very helpful for when naming big chemicals and also in the future. And it goes for every other hydrocarbon. Ethane becomes ethane. Now, so it's 2H. It's exploded. But the thing is with this as well, because there are missing hydrogens, there can be a double bond formed here, but that's something slightly different. Something a bit different. Now, from the information I've told you, we ask a little question. What is this called? Give you a sec. So, C3H7. What is the name of this hydrocarbon? This alkane. Did you get it? The name is propyl, since a hydrogen has been removed. Now on to a little bit more complicated, but another question. What is the name of this, as well as the chemical formula? The chemical formula is like using symbols. Can you guess? So there's 1, 2, 3, 6, which means it's hexene. Very good. Hexene. You can write it as C6H14. Good. That's that. Now, something called alcohol groups, which I didn't say at the start of the video, but we're also doing about alcohol groups. An alcohol group is an alkane, a hydrocarbon, with an OH group, like I said a second ago. So, we have the humble methane, CH4. And what happens is hydrogen off, and instead we replace it with the OH. So it still has the same amount of hydrogens, just has an extra oxygen, CH4O. And you would call this meth and ol. And you'd replace the ane at the end of every hydrocarbon, hydrocarbon for anol. Anol represents the OH group. So this is methanol. And if you know what alcohol itself is, not the group, not the type of group, but what itself is, it's ethanol. Alcohol is ethanol, F and O, which means it's C, C, there's an OH group, H, that's not a H, H, so C, kind of weird. CH3, CH2OH. That's how I'd write it. Chemical extended chemical formula, so unsimplified. So CH3, CH2, and OH. And when writing it, you know, in the method where it was kind of like spikes, like weird patterns. Also, if you see me doing that with my neck, it's just because my crack of my neck, because it's a little bit tensed up. Anyway. So you'd write it like this, so OH at the end. So since remember OH means anol at the end of an alkane, and to find what an alkane is by looking at the structure like this, you count the amount of carbons. So what is the chemical formula and name for this alkane? You know? give it a sec. It is, because there is 1, 2, 3, 4, 5 carbons and an OH group, it's pent and ol. So C5H12O, or alternatively CH3 CH2, and it would be 4 times then an OH. The reason why it's 4 times is because you do it like this. C, 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 OH. Don't know if you can see that, but yeah, I don't have much space. Actually, hold on. Redo it. Okay, so pentanol. Alternatively, write it. I know I'm covering, but so you would have hydrogen, for carbons, and remember, as I said earlier, with the brackets, you put a set of brackets around the chemical, the compound, or the group which is going to be repeated, and since the H has been removed over here, this is separate. Now we have 4 of these, so CH3, CH2, bracket, 4, OH, pentanol. Now, just before I end the video, I'm going to do a quick question. 2 quick questions, actually. Okay. What is the name of this chemical and what is its formula? Write that down in the comments. And oh yeah, one last thing. How many bonds can nitrogen form? I'm not gonna answer it, but if you type it in the comments, I'll let you know if you're right. Alright, bye, thank you. Hi there, yeah, it's me again. I accidentally ended it, even though I wasn't trying to end the video. I was just trying to create sections, because I was going for a break, so I've done some cookies. Yeah, because I forgot to do combustion. Well, that's what we're doing now. So, let me just put this back up. And remember, put the answer to those questions in the comments, because I will answer them if you actually put them. So, combustion is when you have some hydrogen or just really any fuel and oxygen and a startup energy, and that's how you get fire or an explosion. So an example of combustion, so this is combustion without the extended equation. This is just a simplified version. We're very, very simplified. Fuel plus oxygen. In chemistry, don't do equals, you do the arrow because of reasons. Some startup energy, like you need initial energy, that's why you have to light. Like if you have, let's say some alcohol in a bottle, to actually get it to be on fire, you have to light it. That's the startup energy. Then the oxygen in the container and in nearby, and the alcohol, which is the fuel. And this gives you some amount of CO2 plus H2O. This is standard complete combustion, and I say that for an important reason, which I'll mention in a sec. This is not fluorine, by the way, this is fuel. Now, for the more actual formalized version, you have, let's say, methane, which is a gas, like we said earlier, CH4 plus some amount of oxygen becomes some amount of CO2 plus some amount of H2O. The reason I'm saying some amount, because if in chemistry, and then just in general in the sciences, you can't create matter or destroy it. And in this instance, that rule has been broken. That's why you have to balance the equation. So there is one carbon and 4 hydrogens, 2 oxygens on this side. There's 1 carbon here, so that matches, 2 oxygens, that matches, but there's an extra oxygen, so that doesn't match, and we're missing 2 hydrogens. So we have an extra oxygen and missing hydrogen. I think, oh, well, the equation's wrong. It's not, because you can, I don't know why I wrote that out, but I guess we're just going for that. You can remove you can place a number in front of a chemical without actually changing the chemicals. If I change this number to be O3, that'll be ozone or trioxide, which is a completely different thing. Instead, you put the number in front. This means you have, let's say if it was two lots of oxygen. So for the combustion of methane, as I did a little second ago, what you could do is you can write out in symbols how many of each there are and try and balance it. So the hydrogen, you can get 2 of them. So that means you have 2 oxygens. It's 2 plus 2. Then there's 1 carbon, so you put 1 there. That's 2 plus 2, that's 4. So, and then you divide that by 2, you get 2 oxygens. Does this work? So if you have 2 oxygens, then you have this. So that goes to there. This goes to there, since there is now 2. This to here. This to here. And yeah, that's simple, complete methane combustion. And now, as I said, octane. Octane is interesting. I'm not going to do too much in it, but I think it's to my knowledge that octane is used in car fuel. Is it diesel? No, it's not. It's not diesel. Something related to that. Anyway, we have, let's say we have an alcohol. We're going to do an alcohol group. Let's do ethanol, because alcohol, as I mentioned earlier. F and O. Remember that? Okay. Let's do the chemical for it. So we have CH2 6 plus some amount of oxygen equals what gives you CO2 and some amount of H2O. This is the form, kind of standard form. Now we have to do it in a way where it actually states where it doesn't break any rules of physics. So CO2, which is carbon dioxide, plus H2O. And carbon dioxide is, we need it in the atmosphere, but too much of it is bad, and that's one of the reasons why global warming is happening. Water vapor can also contribute to the greenhouse effect, which carbon does, and methane, and other gases. But water vapor isn't as bad, plus it comes down in rain. So water vapor good. And carbon dioxide also good, and carbon dioxide is written like this. So a double bonded oxygen. Anyway, back to the combustion. So we have two carbons, 6 hydrogens, and 1 oxygen, 2 oxygens here. So because we have 2 here, we'll put 2 above here. So, if it's 2, that means this would be 4 oxygens. And for this, it would be 3. That means we have 3 oxygens. 3 plus 4 is 7. And since there is an O over here, we can take one of those away. So it's 6. And can we divide 6 by 2? Yes, we can. 3. Which means this is 2. This is 3. We get combustion, complete combustion of ethanol. 3 oxygens, 2 carbon dioxide, and 3 water vapors. Now I'm going to write the equation. I'm going to write the combustion equation for you to do. This is going to finish up the video officially now and not accidentally. It's going to give you one combustion equation for you to do. Now, what number goes here for this equation to be correct? So, number 1, what is the name of this chemical? And what does the combustion of the chemical look like? Put it in the comments and I will favourite your comment if it's correct. Actually, you know what? I'm not going to do a comment thing. I'm just going to... So, I'll let you work it out. So, obviously, pause it. I don't know why I was doing a comment thing, but because I've already done quite a lot of that. So, this is pentanol. And you write it as C5. Actually, let's remove this. C5H12O plus 2 gives us CO2 plus H2O. So again, you know, you do the hydrogen 2 CO. So we have all this. Now, if we put 5 above here to stay here, it would be 5. That means it would be 10 oxygens. And we have 12, so that'll be 6 oxygens. 10 plus 6 minus 1 is 15, which is not divisible by 2, giving you a whole number. So, it must not be that, which means we need to put a 2 times. So, that means 10, 24, because it's 2 times, which means we put 12 here. That's 12 oxygens plus 20. So we get 30. What was 32? You need to take 1 away. Actually, wait, hold on. Hold on, I feel like I've done that wrong. Hold on. No, pentanol can be combustible. I don't know what I'm doing. So C5H12O plus O2 CO2 plus H2O. Yeah, so because since that's odd, use 3. If you did, wait, 3. I don't know why my brain's going a bit frustrated, but I think I'm going to keep this in because it's good to see if something goes wrong. This is 3 is 15. I'm going to try and wrap this up. It's 30 plus 3 is 6. Oh. I understand. I've got to do the oxygen isn't on its own. It's not on its own. C5H12. I'm silly. Why have I done that? I'm silly, aren't I? Okay. Okay, so that's 2 O's. So 2 oxygens minus the 32. So that's 30, which means this is 15. So if you put that, 2 for the fuel, 15 for the oxygen, 10 for the carbon dioxide, and 12 for the water vapor, you're right. Sorry, got that wrong. But yeah, that concludes our first lesson here. Tell me how I did. Like if you like it. And I can't make it too long because, as I said, the editor's special. But thanks. Goodbye.